Hello, everyone, and welcome to the Department of Energy's SBIR STTR FY24 Phase 1 Release 2 Topics webinars. My name is Zina Al-Yusuf. I am with the DOE SBIR Programs Office, and I will moderate today's webinar and provide you with some basic topic information as it relates to Release 2. Following this introduction, you will hear from topic managers that oversee topics 2 through 8 and 29 through 30 as they clarify their expectations and answer some questions that you may have regarding their respective subtopics. During this webinar, you may submit topics related questions via the Q&A box located at the bottom of your screen. Please include the topic number and the topic and subtopic number with your question. This is very important, and this will help us keep track of questions submitted during the webinar. So please remember to include the topic and subtopic number with your question. We will group the questions and present them to the topic managers following each topic presentation. If you have a funding opportunity announcement or other non-topic related question, please save these questions for the Release 2 Funding Opportunity Announcement webinar scheduled for December 15. We will post the recording of this webinar along with a copy of the presentation on DOE SBIR website under the Funding Opportunities webpage. The programs participating in today's webinar are Office of Defense Nuclear Non-Proliferation Research and Development, topic 2 through 8, Office of Nuclear Energy, topics 29 through 30. This is the third and final webinar that will cover the Phase 1 Release 2 topics. There are 6 programs participating in this release, and we have about 117 subtopics. Today, we will cover the topics from the 2 programs we mentioned earlier. As you can see, the topic document was issued on November 6th, and this week we are hosting the webinars. The funding opportunity is usually released 3 to 4 weeks after our topics are issued. We do this to give you the opportunity to read through the topics document and ask questions so you can make up a more informed decision as to whether or not you might have something that is responsive to what we are looking for in this release. The most important date that you need to pay attention to following the opening of the FOA is the letter of intent due date, which is the first step you need to take in order to submit a full application. DOE is the only federal agency that requires a letter of intent. It tells us who you are, what topic, subtopic you are interested in applying for, and a little bit about why you think you are responsive for that subtopic. So basically, if you do not submit that letter of intent, then you cannot submit a full application to the funding opportunity. As I mentioned, we have 6 programs participating in this release. We covered topics 1 through 28 over the last 2 days, and today is the third and final topic webinar. All 3 topic webinars, recording and presentation will be posted on our website under the Funding Opportunity webpage, and for you to access anytime you need to. The funding opportunity is scheduled to be issued on December 11. After that, we will have the funding opportunity webinar on December 15. In this webinar, you will hear from the DOE SBIR STTR Outreach Manager, Eileen Chant. Eileen will provide an overview of the application process and go over a few changes to the program. So you will want to register for that free webinar. It is an opportunity for you to ask questions as it relates to the actual application process. However, today we are going to discuss the topics in just a little more insight than what is provided in the topic document. Please remember to join our mailing list if you haven't done so already, so you can receive notification from us when topics are released, webinar registration, and some good information applicable to each cycle as we move through the phase 1 process. We would like to bring to your attention that we use GovDelivery, a news application platform, and please work with your IT group so they allow you to receive these emails, and you will not we send good emails with information that will help you. We also have phase 0 application assistant program. It's free to you. It is open now, and the phase 0 application assistant program is available for first time DOE SBIR STTR applicants. Participants receive an individual coach who is an expert in our application process. Please go to our website under the applicant resources and click on the link for the DOE Phase 0 program to determine your eligibility to apply to Phase 0. Just to give you a clear picture about our topics, they are created by DOE program managers and define important technology breakthrough needed in the R&D areas that support the DOE mission. The topics are written in a way that support the topic manager in his or her role in his or her office. Many of these topics are related to the topics they are sponsoring in one of their universities or national labs. When you go through the topics document, you will see that the topics are arranged by program offices and organized alphabetically and numerically, and that is the way we are going to refer to them. What we ask you first to do is to read the topic, subtopic, and reference information that is provided to get a little more context as to what the topic managers are looking for. When you do get in touch with the topic managers, it is for clarification purposes. We are not asking them to tell you whether or not it is a fit for what they are looking for. In other words, the feedback they give you is to help you determine whether or not your innovation would fit what they are looking for. At the end, the decision to apply is yours, regardless of what you might hear from the topic managers. The decision is yours. So what's a topic look like? Here's an example for you. We always have a topic header, that is the blue bar you see below the topic title and above the topic description. It gives you very important information, like if the topic accepts STTR, yes or no, and the maximum award amount for that topic. Not all topics have the same information. They vary by program and by topics as well. So please do pay attention to such information. The general topic description explain what the topic is about and maybe some context on where it falls within the mission of the program. Below that, you see the subtopics that describe specific opportunities in which proposals are requested. You will notice that a good number of the topics have other subtopic. Under this subtopic, you can submit proposals that fall within the general topic description, but do not fit with any other subtopics. After each subtopic, there's question-contact, then the name and email address of the point of contact that you can reach out to with your questions. Please note that every SBIR and STTR application must include the topic and subtopic to which you are applying for. That's just a brief overview, and now we will start with the first topic in today's webinar. Topic 2, and John, are you online?
Hello, can you hear me?
Yes, go ahead.
Okay, so my name is John Lazarus. I'm the, I guess, technical topic manager for this topic. Our topic's titled Quantum Sensors for Underground Nuclear Explosion Monitoring. So this topic is coming out of the Office of Nuclear Detonation Detection within Defense Nuclear Nonproliferation Research and Development. This topic is specifically geared towards sensor development for underground detonation detection. And we're interested in detecting and sensing signals that can be generated by underground detonations, such as seismic signals in the subsurface, infrasound signals in the atmosphere, and other signals of diagnostic value, such as electromagnetic or acoustic signals. One sensor category of interest is quantum electromagnetic sensors, which can provide potentially useful detection thresholds in configurations that can be fielded with small aerial footprints, minimal weight, and low power requirements. So we're soliciting research in quantum sensor approaches, which may be useful in underground nuclear explosion monitoring applications. Specifically, we're interested in methods that would lead to sensors that are fieldable in rugged environments. So some example characteristics would be the ability to deploy the sensor in any orientation in the Earth's magnetic field, data rates of 2,000 samples per second for millisecond timing resolution, and the ability to operate in a broad range of temperatures. Subtopic B is a little bit more general. If your company has capabilities or proposals to improve other seismic sensor types that we have that are of interest, other types of seismometers or infrasound sensors, we're also interested in hearing about those proposals. So those are our two subtopics. I'm happy to take any questions if there are any.
Let me see. I don't see any questions. Please include the topic and subtopic number with your questions. Okay, topic, subtopic 2B. Let me see. I don't see the question. It just says.
Okay, I can see it.
Okay.
Give me a second to read it.
Okay.
Yes, so the question is, am I able to say if hardware that substantially enhances capabilities of existing sensors, but is not a sensor itself, would be considered responsive to the subtopic? I would say the answer is yes, that would be of interest and would be responsive.
Thank you. I don't see any other questions, so we can move to the next topic. I see some of the questions, regarding the LOI and contact the program manager. Yes, you can contact the program manager. Regarding the LOI, or some of the questions are not technical, please save these questions for the funding opportunity announcement webinar on December 15 that will discuss the application process. For today, we're just taking questions with regarding the topics, i.e. Technical content questions. Thank you. Thank you, John. I don't see more questions to topic 2, so we'll move to the next topic, topic 3. Christopher?
How about now? Am I coming in clear?
Yes.
All right, awesome. Hi, so Chris McCartan, I'm the PI for the radiation-resistant plastic encapsulated microelectronics topic for the space-based nuclear detonation detection program. So what we're looking for here is we'd like to develop and kind of improve methods for radiation shielding when it comes to components that are destined for space applications. We'd like to explore some applications that would probably result in some decreased size, weight, and cost parameters, as well as the end goal to increase the lifespans of electronics on orbit. Primarily, we're looking at the MEO and GEO kind of orbit range there, but LEO is not excluded. Yeah, in addition to the increased lifespans, we're hoping to yield from these increased radiation shielding. We're hoping that'll lead to increased processing power on orbit, since a lot of processors that are utilized are specifically designed for space utilization, or a generation or a couple generations behind what's commercially available. So we'd hope to kind of gain access to this increased processing power, maybe through this kind of technology. That's about the grand scheme for topic A, but it also kind of encapsulates the subtopic B. Doesn't have to be specifically tied to the PEMS kind of topic, but anything that can kind of result in these kind of benefits to our program, we're kind of exploring. Are there any questions?
Let me see. No, I don't see any questions. Oh, no. That's for topic 2, and John is answering that. No, I don't see any questions, Chris.
Okay, if any pop up, I can just answer them in the chat for you.
Thank you so much. Thank you.
Thank you.
Hi, this is Paul Adamson. Can you hear me?
Yes, I can hear you, Paul. Go ahead.
Okay, so I'm the program manager for the data science portfolio and defense nuclear nonproliferation research and development. And for this topic, so red teaming and evaluation of AI foundation models, complex, very resource intensive process. So we're looking for frameworks and methods to approach this process of evaluation and red teaming in a more systematic and cost effective way. These approaches should support various modalities of interest. Ideally, they'll involve development and integration of novel benchmarks, metrics, aggregation mechanisms, and/or uncertainty quantification. It should also include considerations for task weightings, as there are many reasons to believe that tasks should not be equally weighted. We're really not interested in typical leaderboard approaches with single accuracy or simple F1 metrics, for instance. F1 metrics are known to ignore things, the true negative rate, which is particularly relevant to our domain of nuclear nonproliferation. So what we're looking for in a phase 1 effort would be a report with a description of the framework or methodologies, along with the plan to implement and demonstrate evaluation and red teaming of several different open source or industry type foundation models within nuclear nonproliferation relevant tasks. Some key metrics that we're looking for when we evaluate proposals are things like, is the framework able to scale to evaluate large numbers or very large size foundation models, potentially, like I say, of large size, and also can it be adapted to a wide array of modalities, i.e. data modalities and various different tasks of relevance to nuclear nonproliferation. We're also interested in these methods and frameworks that would integrate with existing or customized machine learning, foundation model metadata management approaches, also model versioning systems to extend that to like benchmarks and other components, versioning of other components for the ML pipelines. And that's it.
Thank you. Let me see if there are any questions. There's a question for 4A. Is there a place we can go to know what nuclear proliferation tasks you would be interested in?
Yes, there's one particular reference that's provided in the call to the SciTune framework. That's a really good example of a typical downstream task that we're interested in.
Are there particular use cases or downstream tasks you can provide that could scope/focus the development of the tests and metrics?
Yeah, same answer there. The reference that we provided to SciTune is a really good example of the types of downstream tasks that that is of interest.
Okay. In the references, there was a mention of SciTune. What are your current challenges with SciTunes?
Like I mentioned in what I just said, our real challenge is being able to evaluate very large foundation models and large numbers of different foundation models at scale in a systematic way. So we're looking for frameworks and methodologies that can approach that with rigorous statistics and a systematic approach.
Okay, thank you. I don't see other questions. So when
I see a question. I think it's intended for me. Are you interested in image, video modalities? Yes, we're interested in pretty much just about any modality you can imagine. Text, imagery are like typical modalities currently employed in foundation models, but we're also interested in other modalities.
Okay, thank you so much. Thank you. Let me just do that. Thank you. We'll move to the next topic. Topic 5, Hank?
Yes, Zina, I'm here. Can you hear me? Zina, can you hear me?
Yes, I can hear you. Can you hear me?
Yeah, I can. Yeah, so topic 58-05, it's about autonomous radiation sensing and mapping. So as many of you know, there's a significant advancement have been made over the years, especially in robotics and autonomous navigation. These technologies have begun to infiltrate into the field of radiological and nuclear detection in recent years, but it's still in its infancy. The radiation detection, nuclear detection, radiological and nuclear detections largely remains to be manual operations these days. So there's a need to fully leverage robotics and autonomy for nuclear detection for enhanced capabilities as well as human safety in many of the applications, not limited to NSA. So this topic encourages developers to develop fully autonomous radiation detection technologies, leveraging these recent advances in the field of nuclear sensing, computer vision, AI, machine learning, as well as unmanned aerial and ground vehicles. The technologies would enable remote operations without human intervention and deliver real-time data fusion capabilities, as well as providing red nuke mapping, geolocation, and visualizations to the operators. Systems with networking capabilities, as well as radioactive materials quantification capabilities are highly desired. The topic also has some other system effective considerations listed in details. Potential development paths could including focusing on a single autonomous system in phase 1, and then in phase 2, kind of expand to autonomous sensor networks. Potential transition partners could including DOE, NSA, such as a tool set for nuclear emergency support team, the second line of defense at NSDD. Department of Defense and DHS are also highly interested in autonomous sensing. So this is kind of topic A, but topic B is kind of basically anything beyond what's described in topic that can achieve the same autonomous sensing capabilities. I'm happy to answer any questions.
Thank you, Hank. There's a question for 5A. Who will be testing and qualifying this solution? Who do you see purchasing and using this solution? Would the solution be integrated into an existing product or workflow, or do you require a self-contained inspection mapping package?
Yes, so regarding who's testing, well, much need to be worked out, but there are potentially 2 avenues. We can have some kind of laboratories independent assessment for the technologies, different technologies. We could also give it to our stakeholders, and we have stakeholders within NSA and outside of NSA. They could potentially evaluate your technologies. Would the solution be integrated into existing product? To be honest, I don't think such an autonomous system largely does not exist in the existing tool set. So it has to be self-contained, not instead of integrating into existing system. Maybe later on, some other tools can be integrated onto the systems, but not for the immediate next step. Who's going to purchasing? I think I already talked about number of potential stakeholders. They are all very interesting autonomous and especially quantification capabilities.
Thank you. There's another question. Are you specifically looking for integrated hardware solution, or with software, algorithmic, AI, ML solutions intended for existing or notional hardware fit with your topic, with this topic, sorry?
Yeah, so we're looking for fully integrated hardware with firmware, software, fully integrated. Basically, it's a standalone, fully autonomous systems without any human interventions.
Thank you. This is for subtopic B, other. Does our research have to involve furthering the R&D of both hardware and software, or can we focus on software system capabilities?
Well, it's kind of up to you. There are plenty of hardware and software already exist to address these problems. I think it's mostly about a matter of integration. But if you're willing to spend, I mean, the SBIR program is kind of limited in resource. If there's plenty of sufficient resource, you are encouraged to do new R&D in both hardware and software.
Is this system a robotic-based system, or some functions of it, for example, map generation and navigation? Can we contact you after this webinar?
Absolutely, you can contact me. Yeah, so we're primarily looking for autonomous unmanned platforms, aerial vehicles, ground vehicles, those kind of platforms. It's not going to be based on human operated platforms.
Okay, thank you. I don't see other questions. So we'll move to the next topic. You can stay and answer the topics in the questions in the Q&A box. Just type the answer, please. Would really appreciate it.
Yes, the next one is still mine.
Okay.
So number 6 is high energy X-ray sources for field radiography. some of you may know high energy radiography is an indispensable tool for nuclear incident response due to their high penetration capabilities through dense materials, especially for field diagnostics applications. And at present, the 7 MeV Betatron accelerator systems are used for this purpose in the field diagnostics. But the Betatron has some limitations in its adjustability in energy and dose output. And making things even worse, the geopolitical tensions, especially with the war in Ukraine, the Betatron has suffered severe supply chain issues because parts of the Betatron are made in Russia and can only be made in Russia and are assembled in UK. So the parts from Russia is currently not available. So in recent years, DNR&D has played a big role in developing alternative X-ray sources, not only for radiography, but also for radioisotopic source replacement, with a heavy focus on linear electron accelerators. So this topic, under this topic, we are seek to develop, I think mainly it's going to be based on Linux-based X-ray sources systems that is capable of replacing the 7 MeV Betatron. And we are hoping that whatever technology proposed are able to swiftly reach high TIR levels for field use. Effectively, in the nuclear incident response field, people are waiting for these technologies. So the topic has listed some of the key threshold requirements. I won't repeat over here, but the other technologies, other than the Linux-based technologies, are also welcome if they can meet these requirements. As I said, the technology will be immediately transitioned to nuclear emergency support team field diagnostic tool set as soon as it's matured. There's in that field alone for field diagnostics, there's dozens of such systems are required in field radiography. The unit cost, we are looking at the current Betatron, albeit they are not available right now, but they usually cost about 150K per unit. So if you can achieve that kind of cost per unit, that's competitive. And I think that's all I have to say. Any questions?
I don't see any questions. Again, I would like to remind our attendees to please submit the topic and subtopic number with your questions. Okay, we can move to the next topic, and it's topic 7 also. Hank, go ahead.
Okay, yeah, so next topic is about alternative radiological source technologies. So this topic primarily support the needs of the NSA Office of Radiological Security. So again, we have a clear target stakeholders for this particular topic. The OIS, Office of Radiological Security's mission is to replace radioisotopic sources with electron beam and X-ray sources for a broad range of applications, such as medical device sterilization, food irradiation, radiation therapy, IO well logging, and other industrial applications. Some of you may have attended the June 2023, that's earlier this year, OIS held an industrial day in Crystal City, Virginia. And during that 2-day industrial day, questions are asked on why it takes so long and why there's such a resistance to transition new Linux-based electron and X-ray sources to replace radioisotopic sources or ethylene oxide approach currently being used for sterilization. And one of the main reasons is that there's a serious supply chain issues for the parts to sustain the operations of the accelerator-based systems, particularly with regard to the supply gap in RF systems, such as the classitrons, magnetrons, as well as other accelerator components. So with this topic, we are primarily seeking to help developing a US basis toward a sustainable accelerator manufacturing, with a focus on reducing supply cost, as a lead time, as well as reliable maintenance. We are also trying to minimize the lead design of the system components, avoid single point of failure in the manufacturing process, as well as improving the power conversion efficiencies from electrons to X-rays. So any promising technologies out of this program will likely be transitioned to RIS for further. Assume you have finished phase 2 development under this program, you will likely be transitioned to RIS for further phase 3 development opportunities. And I'm happy to answer any questions.
Okay, we have 2 questions. It's related to the previous topics. I'm just going to read it for you. Any flight time limit? This is for topic 5. Any flight time limit if a drone is used? Are we offering our own drone and detector?
Yeah, so I would say that the endurance of the UAVs is a big consideration. I would say you should have at least 15 minutes of operational time, air time, with your payload. I mean, fully loaded with your UAV. We're not DoD, so we have some flexibilities in choice of what type of UAVs you want to use. I mean, DoD has a very strict approved UAV list, but we have some flexibilities. But cybersecurity, since I think it's a concern to everybody, so keep that in mind as well.
Okay, thank you. There's a question for 6A. We innovated using synchronized UAV fleet hives, aerial inspection. Are you interested in this?
Absolutely.
Okay, thank you. Could you please clarify what should be done if phase 1 for this topic? What should the phase 2 TRL level be?
I think it's a 6, right? 6 is high energy X-ray sources.
Yeah.
Okay.
Let me go.
Phase 1 should be done. What should be phase 2? Okay, so phase 1 is typically is proof of concept, right? But given that there are lots of, we want to have high TRL by the end of phase 2, and there are lots of research already being done in this field. I would, at the minimum, I would expect a kind of first version of prototype. Of course, I understand that the phase 1 budget may not able to deliver that, but at least the proof of concept, very strong proof of concept.
Okay, then there is a question regarding 7A. Do you think a high power RF window would fit to the topic?
Yeah, I would say so, but I really have to check with OIS if that's something they're interested in continuing phase 3. I think they give us a couple of high priority items. RF windows, not more of them right now, but maybe we need to do some more research and find that out, because that's need to be done.
Okay, so should the person send you an email directly?
Which one?
Regarding 7A?
Oh yeah, absolutely, yeah.
Yeah, so please send an email to the topic manager, to Hank. The other questions, can we contact you directly? Absolutely. You can start contacting topic managers at this point. So that's it. Hank, thank you so much. We'll move to the next topic. Topic 8. Chris, are you online?
I am, thank you.
Go ahead.
So let's see. I'm Christopher Ramos. I manage the remote detection portfolio for DNN R&D, and our definition of remote is to implement sensing capabilities that are at least 100 meters or more away from an intended target of interest. And in executing that mission, the remote detection team usually helps to develop things like imaging focal planes. We're looking this year at wanting to try to take advantage of some quantum resonance effects that we have seen in the literature and see how far, make some investment to see how far the small business community might be able to take some of these ideas. For the B topic, the demonstration analysis of a phased array gravity sensor, this one is interesting. The technology exists out there to do the quantum gravimetry with the atomic interferometers, and we are wanting to investigate the benefits that we could get from doing a phased array version versus the sort of single point collections that we currently do. And then the C topic, we're looking at hyperspectral imagery analysis, but not over land. We're looking at doing maritime or oceanic HSI analysis, and that's a very hard problem to do because the water surface is much different than the land surface is. And so we would imagine that there would be some sort of computational component involved in that so that we could better and in more detail understand the differences between doing hyperspectral imaging over bodies of water versus land and what things we can learn from them. These are phase ones, so we expect these to be, very low technology readiness level and proof of concept. So there will probably be, a good chunk of modeling in some of these. If your companies have some good ideas and prior experience in these areas, it might be something that you could maybe jumpstart to production. We will see. It would be interesting to see the responses that we get to these proposal topics. And I will end my remarks there.
Thank you so much. I don't see any question in the Q&A box, so we can move to the next topic. Thank you, Christopher, appreciate it.
Thank you.
Okay, we move to topic 29 and we'll start with David. David, are you online?
I am. I was just trying to figure out how to unmute the double mute. Right. So I'm the program manager for the Nuclear Energy Advanced Modeling and Simulation program. So that's subtopic A in this area. We have a lot of subtopics, so I'll try to keep it pretty brief. Most of the discussion of what we're looking for is in the topic description itself. I'll highlight that the real focus of this is looking for applications that apply tools that we've already developed or expand on them somewhat, but particularly to apply them to industry problems and try to get increased use. That could be either advanced non-light water reactors or light water reactors. Either one is good. We've listed a few examples in the description of possibilities. That's not exclusive. But I want to highlight kind of the last one about using the tools with existing plant operational data and really try to demonstrate to industry and quite frankly the NRC maybe what could be done with advanced modeling and simulation tools, particularly the ones we've developed. But yeah, there's a lot of space to explore there. In the past, we've gotten a lot of received and funded quite a few applications on meshing and mesh refinement, interfaces and workflow kind of tools. So if you're thinking in that direction, you really need to look through the list of projects that have been funded in the past, which I believe are still on the SBIR website. I'd really like to see applications that engage industry, meaning nuclear reactor vendors or utilities, but also demonstrate an understanding of the regulatory requirements or expectations, that the industry operates under. I will also note that getting access to the computer codes are non-trivial. And so, you'll need to look into what's required to do that and make sure that you'd be able to do that and actually execute the project. There's a couple of ideas I've thought about specifically, including say machine learning based on data for light water, operational improvements. And also there's a phenomenon called CRUD, Chalk River Unidentified Deposits, where deposits on the nuclear fuel rods can change the way the reactor behaves. I think there's a lot of opportunity for someone to demonstrate modern techniques and tools that could really reduce costs for the industry. So that's what this topic's about, and I'll look for questions. Thank you.
Thank you. I don't see any questions. Thank you, David. Derek, are you online? Oh, there is a question. I'm sorry. Do we have to cover all three areas of focus, or could we only focus on enhancement of instrumentation?
Yeah, I'm trying to find where the enhancement of instrumentation is, but I guess let me just address it more generally for the modeling and simulation one. As long as you're meeting that statement about, applying the tools that we've developed, maybe with additions, but to address industry problems and for increased industry use, as long as you hit that, it'll be considered.
Okay, there's a question. Where can we find references for these subsections? Are there future webinars we can attend to get additional information?
I think they're talking about these subtopics in general. And I would say that's why we've listed the responsible parties for each of them. If something's not addressed here, as you said, they can reach out to us individually.
Thank you. I don't see, let me see, no more questions to 29A. So we are going to move to 29B. Derek, are you online? Okay, 29C, Christopher?
Hello, can you hear me?
Yes, I can hear you. Go ahead.
All right, so I'm Chris Barr, the program manager for the Nuclear Science User Facilities. This topic is focused on non-destructive methods to assess material embrittlement of reactor pressure vessel steels under operating service conditions. During long-term operation under intense neutron radiations, reactor pressure vessel steels can degrade. This degradation is associated with changes in the underlying microstructure and subsequent changes in the mechanical properties. Typical methods require periodic destructive testing by Sharpie impact. For this topic, proposals are sought for development of in situ methods to assess mechanical performance, specifically embrittlement of reactor pressure vessel steels under operating conditions using non-destructive methods. This may include sensors and detectors to evaluate embrittlement reactor pressure vessel steels under prototypical reactor environments. And that's all I have.
Okay, I see that Derek is online. Let's just give him a few seconds to unmute. For 29B. Hi, Derek, can you hear me? Derek, can you hear me?
Dirk just mentioned in the chat that he's having microphone issues.
Oh, okay. Let me see. I apparently having microphone issues. Okay, we'll get back to Derek. We'll move to the next subtopic, which is Daniel, 29.
Yes, I'm online.
Okay, go ahead.
Okay, so subtopic 29D, advanced sensors and instrumentation. This focuses on sensors and instrumentation that support three key areas of the NE mission. That would be supporting the continued operation of the existing reactor fleet, supporting advanced reactor designs. That would include, light water reactors, molten salt reactors, liquid metal reactors, high temperature gas cooled reactors. So a number of new reactor designs, as well as supporting fuel cycle and material testing. So the key takeaway from this subtopic area is that we're looking for either enhancing the capabilities of existing sensor technologies or developing new sensor types. But of course, the intent behind SBIRs is to lead to commercialization of these technologies so that they can be adopted by the nuclear industry. So for applicants, keep that in mind, that the timeline between a phase 1 and a phase 2 is ultimately, the goal is to have a commercial product available for adoption. This topic area also includes developing advanced control systems. What we'd like to see, if applicants pursue that avenue of this subtopic, is really describing what sort of problem they're solving with that control system they're developing, how it's integrated into controls, instruments, actuators, and basically what is the end use case. Is the advanced control system elevating the capabilities of a system over PID control? Is it accomplishing a new capability for existing reactor fleets or advanced reactors? So we'd like them to call that out. And then the final thrust of this subtopic is investment into or enhancing either instrumentation or advanced control systems through the use of artificial intelligence and machine learning applications, but also looking at also developing digital twin platforms for control systems. And so applicants are encouraged to read through the detailed language of the funding opportunity announcement to get a little bit more context. And there are some other resources that can point to what has the Office of Nuclear Energy invested in the past. So I'd point the audience to asi.inl.gov. That is the program website for the Advanced Sensors and Instrumentation Program, where you can find some of that additional context.
Thank you. I don't see any questions in the Q&A box. Thank you so much. Oh, there's one.
Oh, it looks like there is
Yes.
two.
What
One from-
TRL level are you looking for at the end of phase 2?
Well, ideally, since the goal is to have commercial products ready to be purchased by or adapted for advanced reactor designs or the existing reactor fleet, we're really looking for high TRL. So, preferably TRL 9, but I think that could also encompass maybe TRL 7. There might be some, follow-on adaptation to designs that is necessary, but in general, higher TRL levels. Well, that's redundant. Higher TRL.
There's another question. Fluid flow measurement, single phase such as water only, or two phase such as air, water?
So it's not limited to single or multi-phase flow or two-phase flow. It really comes down to the application. So if you're targeting a reactor design, for instance, if you're targeting an advanced reactor design that's a boiling water reactor, and you're trying to measure two-phase flow in the primary vessel, well, then of course a two-phase flow sensor would be appropriate. But it's not, the scope does not limit what type of flow sensors are of interest. The call is really about having applicants identify a specific use case, and we encourage them to talk to reactor designers or reactor operators for the current fleet to get an understanding of what their needs are, and then basically submit a proposal based on that specific need case. So not limited. One thing that I want to make sure to highlight to the audience, though, and this has kind of come up in the past too, is that in the Office of Nuclear Energy, we're really looking for sensor development that is relevant to the nuclear industry. There are situations in nuclear power plants where you don't need a special sensor to measure flow. But in the nuclear industry, there are situations where you'll need a nuclear qualified sensor, or a sensor that can survive harsh conditions, primarily radiation, temperature, pressure conditions. And those are the technologies that we're very much interested in. If someone's proposing a sensor that is available for use in the outside industry and it just needs to be qualified to nuclear standards, well, then that's not as relevant to us. It's still something that we might consider, but we're really looking for things that are unique to the nuclear industry.
Okay. There's another question. Are you looking for high radiation tolerant material? What is the required fluence?
So construction of, so I guess this is also pointing to a sensor related question. It depends on the application. For sensors that are going to be going near the reactor core, so the harshest conditions would be in core, and we're kind of a broad range to consider for applicants is a sensor to have a reasonable lifetime. The flux in the in-core region may be between 1 e to the 13 or 1 e to the 15 neutrons per centimeter squared per second. So then taking into account the survivability duration of that sensor, that is the sort of fluence, integrating over that time, that is the sort of fluence that they would have to consider as part of their design if they're deploying in the in-core. And then of course, there's near core applications, and then there's near vessel applications. So moving further away from that most adverse condition. And then there's just in containment, and then there's beyond containment conditions. There is quite a bit of literature out there of what those neutron flux levels are. I feel like it would be too much to explain all of those levels, but in core, good rule of thumb is between e to the 13 and e to the 15 neutrons per centimeter squared. Near core is approximately e to the 11 to e to the 13 neutrons per centimeter squared per second. And then at the vessel, and this is in particular for PWR designs, near the vessel is typically less than e to the 11 neutrons per centimeter squared, but it can be, between e to the 11 and e to the 9. So that should give an approximate range. But again, it's up to the applicant to clarify what sort of conditions they are developing this sensor for, and then back that up with what sort of conditions they anticipate, what sort of environment do they anticipate, and really speak to that. If you're proposing a sensor to be deployed in the vessel and it's a PWR, then really you're going to have to call out the radiation environment, the temperature environment, and the pressure environment, and say we're creating a sensor that will survive those conditions for X amount of time. And that X amount of time should be a very practical amount of, or duration. So
Thank
hopefully
you
that
so
answers the
much.
question.
Thank you. Let's go back to subtopic B. Derek, are you able to speak, present? I see that you are online. If not, maybe you can answer questions in the Q&A box by typing the answer. Okay, it looks like Derek still have the microphone issue. So we're gonna move to the next subtopics. Catherine, are you online? Catherine, are you online? I see that you are online, but don't see any connection established. Let's just give Catherine a few.
I don't know if you can hear me, but Kat is chatting in the text box saying that she called in, but she can't unmute.
Okay, let me see. Let me try from my side to maybe I can unmute her. I don't see.
Her phone number is 240-474-2651. So it would be that line.
And okay, let me see the phone number. I don't even see the phone number on the list of panelists.
Is she listed as an attendee and not a panelist?
I cannot do anything.
Yeah, I do see Kat's number is listed on the attendee list.
Let me see. Okay, hold on one second. Is it the first or the second from the top list?
The phone number appears as one, or so there's a 1 in front of the number that she posted in the chat.
Okay, let me see what's in the chat.
Can you guys hear me now?
Yes, I can hear you.
Thank you. The audio is not working on my computer, so I have to call in, but apparently it doesn't recognize that I was a panelist from that. So, okay, so we have 3 topics for this particular area. The first one is component development to support liquid metal reactors, specifically electromagnetic pumps, The idea behind this is liquid metal reactors have been demonstrated in a number of countries. Advanced versions of the first-gen reactors have tried to simplify large pumps by using electromagnetic pumps with the ability to operate submerged in high temperature and under radiation conditions. We're seeking applications for collaborative small business partnerships from a U.S. company or companies. We do welcome multiple applicants in one proposal to advance liquid metal reactors. Potential areas of collaboration for this topic include, but aren't limited to, development of a small electromagnetic pump that could be tested in a high temperature prototypic sodium environment, or development of insulation technology for an electromagnetic pump that can withstand high temperatures and gamma and neutron radiation during liquid metal reactor operations. What we would be looking for here from a phase 1 would be a demonstration, like proof of concept and a prototype created. Any testing would take place probably during phase 2. However, we do have the opportunity that, we do have facilities like the mechanisms engineering test loop available to us. This is a place where a submersible pump could be tested. We also have an under sodium viewing loop as well. So again, you would the opportunity for a phase 2 would be there. However, we wouldn't be looking at testing upfront. However, we could give details regarding what the specific qualifications it would be tested in, or the specific conditions it would be tested in. The second topic is roller bearings for high temperature sodium applications. The idea here is we are looking at reducing the cost of the primary heat transport system by using advanced robotic refueling systems. They allow for a reduction in the reactor vessel size and overall reduction in the cost of the reactor. A number of these advanced reactor refueling systems use mechanisms such as gears, roller bearings, ball screws, universal joints, and other mechanical components in liquid metals at high temperatures. Potential areas of collaboration for this topic area include, but aren't limited to, the development of roller bearings for use in high temperature sodium applications. We're looking at, of interest are radial bearings, thrust, and combined radial and thrust bearings. Potential also other areas for this would include coatings for bearings. Again, you're talking about, in this case, them being submerged in very high temperature sodium environments. So we would really be looking for components that could operate under very harsh conditions. The third topic area, under-lead viewing systems for advanced reactor applications, is specifically comes down to one of the important maintenance items for advanced liquid metal reactors, which use various liquid metal coolants like sodium, a sodium potassium alloy, or lead. One of the important maintenance items for these is being able to perform in-service inspections periodically of systems and components that are submerged inside the reactor vessel coolant. The coolants for these liquid metal reactors are opaque, and thus non-optical methods need to be developed and used when performing these inspections. The potential areas of collaboration for this topic area include, but are not limited to, the development of an under-lead viewing system for performing in-service inspection of reactor vessel internal structures. Thank you.
Thank you. Let me see if there are any questions submitted. I don't see any questions in the Q&A box, so we can move to the next topic.
Thank you.
Thank you, Katrina. Janelle, are you online?
She's not, but I am. I'm going to cover for her. Can you hear me?
Yes, go ahead.
Thank you. So we are on scope H, the rapid, inexpensive molten salt property measurement. So this work is focused on rapid, inexpensive molten salt property measurement. In NE, we support molten salt research campaign. That campaign supports reactors that use molten salt as the coolant. One variant of the MSR has the fuel dissolved in the coolant salt, and the other variant uses solid fuel. Our US vendors today are looking at both fluoride and chloride salt to support the development and future demonstration of these reactors. DOE has a need to measure fundamental salt properties for fluoride and chloride salts of interest to those US vendors. So with this work, we are seeking applications from small businesses to develop innovative salt property measurement techniques that are less expensive and time consuming than the current techniques. Molten salts are pretty difficult to work with in some instances. They are hot, they can be corrosive and volatile, and they can also be toxic and radioactive. Some of the properties that we are looking to measure include oxygen concentration, moisture content, viscosity, and a more extensive list is provided in the work scope description, I believe. In some cases like hydrogen concentration, we don't currently have a measurement technique available, whereas for some of the other properties, we are looking for innovative ideas to measure these properties faster and cheaper. Applicants might choose to address one property measurement, or they may choose 2 or more items from the list. That's all I have for that one.
Okay, there is a question. Well, why don't you go ahead and start, present all the subtopics, and then we'll take questions. That would be good.
Okay, I can do that. I will admit that my response to probably all of the questions will be to reach out to Janelle directly at the, at the email address on the screen.
Okay.
But I'll go to the next one. The next few subtopic areas will support the National Reactor Innovation Center, or NREC. And NREC was established by NE to accelerate the development and demonstration of advanced reactors. So any of the activities proposed under these areas will need to support advanced reactors, and activities that only support the current fleet of nuclear reactors will not be considered responsive. We are most interested in activities that will benefit advanced light water, small modular reactors, or any of the non-LWR, non-light water reactor, advanced reactor concepts. So item I is focused on the Advanced Construction Technologies Initiative. One key challenge that continues to face nuclear projects is the cost and schedule for construction. With the ACT initiative, NREC is aiming to make nuclear construction, again, faster and cheaper. So to kick off the ACT initiative, NREC initiated a cost share partnership with a team led by GE Hitachi to develop and demonstrate 3 construction technologies that together could help reduce the cost of new nuclear builds by more than 10%, and could also significantly reduce the time needed for construction. The first of those technologies is vertical shaft construction, which is a best practice from the tunneling industry. The second technology is a modular walling technology that could significantly reduce the labor required on site. And then the third technology is a combination of advanced sensors and digital twin technology that can create a digital replica of the plant and allow real-time monitoring of the structure. With this topic, we're looking to partner with small businesses to evaluate and develop methods, processes, or technologies that can significantly improve the cost and schedule outcomes for advanced nuclear construction. I encourage you to take a look at the NREC ACT website, which was provided in the topic description, to familiarize yourself with the projects that are currently being supported by NREC. We're looking for applicants to propose activities that either are completely different from the technologies and processes that we are already developing, or are complementary to our ongoing projects. In addition to the 3 technologies that we are developing with the GE project, we also have a university project which is focused on open architecture. So please, again, feel free to contact Janelle if you want more information on that particular university project. I will keep on going. So the next item is focused on robotics for advanced nuclear facilities. With this topic, we're seeking applications to develop and demonstrate mobile robotic technologies that will improve economics or enhance safety by reducing human exposure to hazardous conditions, improve quality and efficiency, and aid in emergency response. So for this topic, you can either modify an existing robotic platform to be suitable for advanced nuclear applications, or you can develop a completely new robotic system. And I do want to note that advanced reactors use a variety of coolants. I mentioned molten salts already, liquid metal, and helium, and they also operate at high temperatures. So any robotic system proposed would need to be able to withstand those conditions that are prototypic for advanced nuclear plants. And then topic K, the final topic in the NREC area, is focused on developing supporting technologies for microreactor operations. Microreactors are a cross-cutting category of very small reactors that are being developed to support non-traditional nuclear energy markets. To help enable microreactor development and demonstration, NRIC is establishing the DOME testbed that will be capable of hosting fueled experiments that operate at less than 20 megawatt thermal using high assay low enriched uranium. These tests and experiments will require many support systems, such as transportation, defueling, and shielding technologies. Transporting fueled experiments, shielding experiments during shipping and testing, and fueling and defueling experiments pose unique problems during demonstration of these systems. Hence, we are seeking applications to help develop and demonstrate fueling and defueling systems, advanced modular shielding, and innovative transport options for microreactor experiments. While these applications will have a near-term impact on the use of the DOME testbed, we expect that the capabilities developed will have a broader and really a longer-term impact on microreactor demonstrations and future commercializations. I will say, I think there was a question, not to get ahead of you, I'm sorry, but there was a question earlier on this specific topic that I saw. And so just to respond to that one, it was about transporting, let me see, applications are requested for developing demonstrating fuel defueling systems, advanced modular shielding, and innovative transport options for microreactors that are fueled by HALO, mean that only applications about transporting the reactors are responsive, or also applications about transporting the reactor fuel. And so I would say that transporting the reactors fuel or unfueled would be a higher priority, because that is really a unique challenge for microreactors. Transporting fuel itself is not necessarily unique to microreactors. But then again, there's also the other topic areas within that subtopic.
Thank you. There's also a question, any order of importance for priorities for 29H?
No, I don't believe there is a priority. They're all necessary.
Okay. Are applications responsive only if they measure molten salt in an active use reactor, or also pre-ignition during maintenance and or during decommissioning?
I would assume all of them, but I would reach out to Janelle specifically to see if there are any limitations in the operations.
Okay, thank you so much. Thank you. We'll move to the next subtopic list. Diana?
Yes, hello, can you hear me?
Yes.
Great, thank you. Hi, I'm Diana Lee. I'm the program manager for the microreactor program, and subtopic L is the area I'm focused on. From a 1,000-mile view, the microreactor program is focused on leveraging cross-cutting research and development activities to achieve technological breakthroughs for key features of microreactors, which would reduce risk and time needed to deploy microreactors. So for this subtopic area, we're looking into 3 different areas. One for civilian applications to help really educate us on the economic environment for microreactors and how they can be applied. For example, we have listed here, microreactors could be used for high-powered computing and data centers. So identifying other civilian applications is of interest to us. Second area within this subtopic is helping to support unattended and remote operations of microreactors, which also again helps to support the economic basis of microreactor deployment. And third, we're looking for just a general, any technologies that can again result in significant reductions in microreactor costs and then improve their competitiveness in deployment. I want to highlight areas that we don't want. Specifically, we do not want new microreactor design concepts or non-civilian applications, and we are not looking for radioisotope power source applications. So that's all I have.
Thank you. I don't see any questions, so we can move to the next subtopic. Matthew, are you online?
I am. Can you hear me?
Yes, go ahead.
Excellent. Okay. For subtopic, Mike. These are graphite related topics, and they were inspired by what we've been learning from challenges experienced by China and United Kingdom. As you know, they have their own gas-cooled reactor development and operations, and we're drawing upon some of those lessons. The specific ideas that we cited in the funding announcement are technologies being used or implemented in some of those nuclear programs. And in some cases, these are also technologies being used in other applications, such as medical diagnostics. So in that sense, these are not brand new technologies, but they're technology that would need to be adapted to the unique requirements of current US commercial gas-cooled reactor or molten salt reactor deployment efforts. These applications span most of the life cycle of graphite components, from sourcing and qualification to material acceptance and in-service inspections. And for the last concept that we cited was component cleaning to reduce solid waste volumes and enable reuse of graphite components or materials. In general, we would be looking for a proof of concept in phase 1 that demonstrates an understanding of application requirements and develops an approach that satisfies those requirements. And phase 2 would then include a comprehensive demonstration of the technology as it pertains to that selected application. For subtopic November, we identified these thermohydraulic topics from dialogue with vendors who are engaged in high temperature gas-cooled reactor deployment. The two options cited were mentioned specifically as areas ripe for research and development in dialogue with some of the current vendors. Our intent is to define these topics broadly enough so that they could be addressed in the context of most of the current HTGR design efforts that are happening out there. And again, for phase 1, we're sort of looking for a proof of concept that identifies and addresses the relevant requirements for either of the analyses, whether the helical steam generator or the near wall pebble bed flow. As a final note, we acknowledge that these areas could be applicable beyond gas-cooled reactors. For example, some advanced LWR designs employ a helical steam generator. And similarly, we have molten salt reactor designs that use a pebble bed configuration. For this subtopic specifically, our interest is exclusive to gas-cooled reactors. So I wanted to mention that specifically.
Thank you. There's one question for 29M. Are those graphite components hot? How large are they?
Yes, they're okay. So they're quite large. I think we're mainly talking about the reflector components, for example, in a pebble bed reactor. And you could reference the X Energy and Kairos licensing submittals. They contain some information that can give you an idea as to the size. And they are certainly hot. They're reactor core components. And I would reference those submittals as well as some of the NGNP reports from Idaho National Lab over the years that talk about some of the sizes and temperature ranges that are relevant to gas-cooled reactors.
Thank you. No more questions. We can move to the next subtopic. Jason, are you online?
So Jason is on, but I'm covering this for him. He can correct me if I'm wrong. So for subtopic, what are we on? This topic is about developing the site and structure requirements for advanced reactor installation and designing the site and structures to meet requirements for installation in close proximity to industrial or commercial applications. So innovative system integration and design for integrating those advanced nuclear reactors in close proximity. and developing design requirements that account for physical space and structures required to install, contain, maintain, operate, and control the reactor, the turbines, fuel storage and handling systems, the cooling components, and the thermal electrical distribution systems, and then emergency power as well. That's O. I'm going to cruise on to P in the interest of time.
Yes.
For P, applications here are sought for the development of cost analysis, focusing on reactor manufacturing cost and reactor installation costs. So for that first part, reactor and auxiliary component costs, we're looking at projects that will develop a detailed reference design that focuses on a single reactor type based on understanding of the design requirements and an engineering approach to meeting those requirements. Methods for manufacturing the reactor and auxiliary components will be developed or should be developed in detail to establish the basis for a manufacturing cost estimate. On the second one, reactor installation costs, we're looking for projects to develop a reference cost representative plan for the on-site construction and installation of advanced reactor technologies with connections necessary for industrial applications. The cost of construction and installation of the coupled system will include, but of course is not limited to, site-specific architecture, engineering, equipment costs, labor, materials, fuel, licensing, management, construction, bonds, insurance, and then financing. Some initial notes for this particular subtopic. Please consider heat delivery systems for an industrial application up to the nuclear plant boundary. But this is not to include the costs associated with thermal or electrical systems for the industrial applications of nuclear energy. And then we already have SBIR projects in the past for high temperature gas reactors. And so we're looking for a more diverse portfolio of reactor cost projects, sodium fast reactor, MSR, or advanced LWR systems. And so technologies that are closer to commercial are also desired for that particular subtopic. And then Q, here we're looking to use advanced nuclear reactors to reclaim or recycle polymers, plastics, and resins in consumer products and construction materials. Proposed projects should include a design, process flow analysis, capital and operating cost analysis. The process should also address a broad spectrum of waste feedstocks, which may include those recycled plastics, tires, sorted municipal solid wastes, construction debris, or manufacturing facility waste tailings. And that is all I have for those three subtopics.
Thank you so much. Let me see, any questions? No questions, so we can move to the next topics. Melissa, are you online?
Yes, I'm online. Can you hear me?
Yes, go ahead.
Great. All right. So under subtopic R, small modular reactor capabilities, components, and systems, we're really looking for concepts that can potentially improve SMR plant capability and performance while reducing capital, construction, operations, and maintenance costs. We're looking for technologies or capabilities that can demonstrate and support improved functionality and efficiencies. The proposed concepts can be applicable to any SMR design, whether it's light water, liquid metal, gas, molten salt cooled, or it can be both electrical or be attributed to both electrical and non-electrical uses from the SMR. But we are specifically looking for projects that can be deployed in the time frame that support, sorry, I kind of said that wrong. We're looking for projects that can support these SMRs that are trying to be deployed in the early 2030s. Some things that we're specifically not looking for is we're not looking for new SMR reactor design concepts or instrumentation control capabilities, sensors, remote operation concepts, fuel design and development, and spent fuel storage and handling. Many of those topics have their own unique topic area, and we're trying to draw a line in between the interest areas. one key thing that is always advantageous to have in your application is some sort of project partner, from an actual nuclear technology developer, indicating the use of your proposed concept. Anyway, that's the main tenet of the topic.
Okay, I don't see any questions. So we can move to the next subtopic. Savannah, are you online?
You're gonna get tired of my voice here shortly. I'm gonna cover for Savannah as well, and then mine at the bottom, and I think you see me again as well, but I'm gonna jump into her 4 subtopics, if you don't mind.
Okay, go ahead.
Okay, so advanced and small reactor physical security costs. Here, we're looking to significantly reduce either the upfront capital costs or the operational costs. Applications are sought for new ideas or the revitalization of past work that has evaluated physical security cost reductions, including new physical protection approaches and the use of new technologies. On subtopic T, advanced and small reactor material control and accounting modernization. Here, applications are sought for improved and modernized mass and material tracking software to reduce costs, improve usability, and increase effectiveness associated with mass and material tracking systems to really support material control and accountability requirements for future advanced and small nuclear reactors. For both of these, S and T, I highly recommend that folks visit the website energy.sandia.gov/ARS. It has the work that is already being performed through that program, so should utilize that as a resource. Subtopic U, cybersecurity technologies for protection of nuclear critical systems. Here, applications of interest will develop technologies and tools that will enable nuclear energy system designers, operators, and researchers to characterize cybersecurity of INC components and systems specific to the nuclear energy sector and identify and mitigate cybersecurity vulnerabilities in such components and systems. So here they've listed a number of subtopics. So develop and demonstrate technologies that enable cybersecure digital INC system architecture, prevent, detect, and respond to cyber attacks, and then develop and demonstrate cybersecure wireless technology. You do not have to classify all of these areas, just one is fine. But however, I do want to flag applications not of interest include just general cybersecurity solutions for information technology, INC components and systems, or wireless architecture, and anything not specific to the nuclear power sector. So please make sure when those proposals are developed that it's very specific to the nuclear power sector. The last one is V, light water reactor central alarm station simulator based human factor studies. Applications here are sought in possible partnership, potentially with a company or a university with a strong human factors component. That's a key to integrate these simulators with security modeling visualizations to engage in full scope human factor study with the ultimate goal of moving force on force exercises to that augmented reality and simulated environment. And with that, I will conclude Savannah's subtopics. Again, if there are questions, please reach out to Savannah at that email address right there for her response.
Okay, let me see. There is a question for 29S and V. It's a general question. Where can we find reference for those subsections? Are there future webinars we can attend to get additional information?
I believe this was answered a little bit ago. But I mean, I don't think SBIR is having additional webinars, but please reach out to the contacts on each of the subtopics and they can provide more information on the work that's being done and the priority within their programs.
Thank you. I guess we can move to subtopic W.
Okay, so this one is plant modernization. In here, I think there was also a question earlier. We're looking at any one of the following plant modernization areas. It does not need to be all of them. It can just be one. We're looking at artificial intelligence and machine learning, specifically trying to address explainability concerns, digital twin technologies for the operating fleet. So I want to flag that this particular subtopic area is for the operating fleet. That differs from some of the other subtopics that we've just gone through. This one is specific to that. So digital twin technologies is the second area, and then self-diagnosis and health monitoring technologies. I will say that we've had this subtopic in the past, so please look to see what proposals were awarded in the past so that we can avoid duplication and get some new ideas here. That's all I had for that one.
Thank you. There's a question, plant modernization. There are 3 bullets mentioned in this topic and subtopic. The subtopic states to achieve this mission in the nuclear power industry, applications are sought in one of the following plant modernization area. If the idea covers all 3 bullets, should we mention that or just aim for one of the bulleted items?
I think that's the prerogative of the proposal or of the PI submitting the proposal. We only need one of these areas to be addressed. If it addresses all 3 of them, that's fantastic. If it addresses one, that's fantastic. I'll leave that up to the PI to determine.
Okay. Can you elaborate about current core operation and maintenance work activities mentioned in the solicitation? What kind of operational problems exist in the LWRS?
We're looking to increase efficiency as much as possible, reduce maintenance issues and needs. We can have if the questioner wants to reach out directly, I can go through that with more detail.
Okay. What does the solicitation mean by third-party outsourcing of troubleshooting and diagnosis?
Currently, the sites utilize those third-party organizations to do that.
Okay. We are planning on developing a software focused on heat exchanger operation, digital transformation in nuclear plants. It will include AI, digital twin, and self-monitoring technology. Is this good fit under this topic?
I would need to have a further conversation with the question. I don't know.
Okay. What kind of computer-aided decision-making is sought? Can you elaborate on the corrective action program mentioned at the topic?
The corrective action program is instituted by the Nuclear Regulatory Commission, and so following the regulation prescribed by the NRC is the process that the plants need to follow. Again, that's a longer conversation of what actually goes into that than here. So if you want to reach out, I'm more than happy to walk through that.
Thank you so much. No further questions. We can move to the next list of subtopics. Sue, are you online?
This one's also me.
Go ahead.
So non-destructive examination technologies. This one's going to be real quick. We've had this one here for a couple years. I don't have anything to say on this other than to please reach out to Sue directly. I do recommend looking at prior year awards again to avoid that duplicity, but that's all I have for that scope.
Thank you. And we have a list of 5 questions for 29X. So you prefer that the person who submitted the questions reach out to Sue Lessica directly, or you want?
Yes, she's the contact for that.
Okay. Please reach out directly to the topic manager with your questions via email. You see the email on the screen. It's also included in the topic documents. Tencel, are you online?
I am online. Can you hear me?
Yes, go ahead.
Okay, that's great. Allison is not covering for me, so I am here. Good afternoon, everybody. My name is Tencel Selekler. I am the Federal Program Manager for the Materials Protection, Accounting and Control Technologies Program, MPACT in short. Nuclear fuel cycle is very large, and materials control and accountancy spans the entire fuel cycle. Our program covers the front and the back end of the fuel cycle. MPACT program was established to support domestic advanced fuel cycle developers to address nuclear materials accounting and control requirements. MPACT is a technology-focused program. We focused on developing innovative technologies, analysis tools, and advanced integration methods, such as voltammetric and bubbler technologies for salt systems. So MPACT program researches, develops, and deploys these technologies to enable next generation nuclear material management. So we have both near and long-term R&D development. We develop tools and techniques to solve current domestic nuclear materials accounting and control problems, but also look out to future fuel cycle needs and develop tools and techniques that we feel will reduce NMAC burden and facilitate the implementation of those fuel cycle technologies. We are looking for new and novel MC&A, materials control and accounting technologies, methods, tools to increase the accuracy, reliability, and efficiency of nuclear materials quantification, nuclear material tracking capability in nuclear fuel cycle facilities, and processes and process monitoring tools. Please make sure your applications support any mission. Also, we encourage you to propose any technology beyond the traditional materials control and accountancy methods and techniques for fuel cycle nuclear materials accountancy challenges. What we are not looking for is to address border security, nuclear forensics, nuclear medicine, personnel dose monitoring, and nuclear weapons related R&D, and also remote monitoring we are not interested in. That's all I have, Tina. Thank you.
Thank you so much, Tencel. No questions in the Q&A box, so we can move to subtopic Z. Ming, are you online?
Yes, I'm here.
Go ahead.
All right, thank you. This is Me 10 from NE43. I'm a program manager for Innovative Nuclear Materials program. So for this, the subtopic, Innovative Fuel Cladding Materials and Core Materials, actually we are looking for support of long-term innovative nuclear cladding materials discovery and development for the fuel cycle applications. So that means the TRL level is low. And also, I want to mention is we are not looking for fabrication or study on the current candidate cladding materials or core materials. We are looking for new materials. So specific interest including the new composite or novel the metallic alloy design. Also, we will test and calculation capabilities, investigation of the material's performance under extreme conditions. Because the fuel cladding materials, is contact with nuclear fuel. Outside is faced to the coolant materials. So we need to consider the FCCI or FCMI, and also we have to under the higher temperature, radiation dose, and corrosive chemical environments. So we're also looking for some innovative materials fabrication and manufacturing technologies. So I think the materials, including the coating materials and also the alloy design and the new structure materials, new structure, microstructures and materials. All this topic is under these subtopics. I think that's all for these subtopics. Any questions I would like to take?
No questions. Thank you so much, Ming. We'll move to the next subtopic. Frank?
Hi, can you hear me?
Yes, go ahead.
Excellent. Hello, everybody. It's nice being near the end. That means the really solid few are still listening. Our subtopic, there are 3 areas in our subtopic, and our federal managers in the other 2 areas. I'm the federal manager for accident tolerant fuel area. The other 2 managers, Ken Keller for the metal fuels for sodium reactors, and Madeline Feltis for silicon carbide related cladding work. If they're on, they can interrupt me as we go on. Otherwise, I'll cover the areas as best I can. The accident tolerant fuel area, we have a very vital program that has been fostering several concepts to enhance the safety of light water reactor fuels in usually large reactors under severe accidents. This is beyond design basis. Driven, of course, we started after Fukushima, so you can see where we came from. We already have several concepts that are in various stages of heading toward commercialization, but we're always open to new ideas, and that's the door in the first subtopic area. And so I've indicated very high burnups would be a possibility. So do you have some novel ideas? What about very high burnups, meaning more than 100,000 peak fuel pin average burnup? But there also could be ways of fabrication to improve the overall procedures of what's already done. And the most important thing, since this program is now about 10 years old, is to consider checking in with the national labs. All, several national labs are heavily involved in our program: INL, LANL, Oak Ridge, Brookhaven. And the other contact would be the program technical director, national technical director, Dan Walks at INL. If you want to know more of what the program is doing and to see what might be of interest, I also would say the 3 companies that are or the 4 companies that are involved: Westinghouse, General Electric, General Atomics, and Framatome USA. Obviously, this, I think, cooperation. Now, if you want to know what's being done, we do have an annual report that comes out every year. The last one is out, and we're working on the next one. That should be available probably within a month. If you're interested in that, just send me an email, and I'll be glad to assist. Ken Keller, are you on the line? Okay, Ken Keller's some area supporting this subtopic is improved methods of fabrication related to plutonium and uranium, metallic fuels, that's the key word there. You know, the ways of making fuel are either very old or you know, or haven't been fully developed. We're focusing on metallic fuels because the MOX concept already is in pretty good use around the world, so we're not doing too much in that, although it's not ruled out. But we are focusing on metal fuels. The ways in which the current metal fuels for the fast reactors are made are challenging because they go back to some of the older ways. But they're now limited with the 20% of HALEU. In the earlier days, one can have higher enrichments. And they don't include PU. So right now, the current concepts of metal fuels that we are supporting, either for Natrium or for other programs that you've heard of earlier in the presentation series today, they are still, you know, we're looking how to optimize what's done. Again, if you want to learn more about them, write an email to me or to Ken Keller, and you get more of that. Madeline, are you on the line? Okay, the third area under this subtopic deals with silicon carbide related fuels as they may apply to light water reactors. And of course, the national labs have been really seriously involved with the development of this fuel type to date, and it's already, you know, a proposed item for some of the advanced reactors. But still, you know, we're interested in improving fuel capabilities, production, and with this one, you should think that the next phase might be irradiation or something. So one should think of the future. Again, if you have questions of this area, since it's rapidly developed, and there are past SBIRs that have helped this area get to where it is now, and we're doing testing mainly at INL, but obviously one of the main developers of this has been at Oak Ridge National Lab. So again, I would say write a question, send it either to me or to Madeline Feltus, and we'll get you some answers. So, you know, we think we have a very exciting area, focusing maybe more on the nearer term, but opening the door to how we can move ahead in the fuels area that may support some other concepts you've heard about. That's it for now.
Thank you, Frank. I don't see any questions in the Q&A box, so we can move to the next subtopic. Joanne?
Okay. Okay, can everyone hear me?
Yes, go ahead.
Okay, great. So the other subtopic is just what it says. It's for areas that fall outside the scope of any of the other subtopics that have been discussed today. So if you have any questions, just email those to me, and I'll track down the answers and get back with you. So it's pretty, it's a very broad subtopic. So anyone have any questions?
No questions at this point.
Okay, thank you.
Thank you so much. We move to topic 30, and Tran, are you online?
Hi, Zena, I'm here. Thank you.
Go ahead.
Thank you. Hi, everyone. My name is Tran, and I'm representing the Office of Integrated Waste Management, housed within the Office of Spent Fuel and Waste Disposition. So I'm actually going to be speaking on subtopic A, and I'm actually joined by my colleagues Jorge Narvaez and Jack Wheeler, and they'll be speaking on subtopic B. So for this first subtopic A here, it's related to the rail transportation of spent nuclear fuel. So DOE's primary mode of transport for spent nuclear fuel is expected to be by freight rail. To address questions and concerns about the risks of spent nuclear fuel transportation by rail, we're really interested in state-of-the-science modeling and visualizations, to represent types and causes of plausible spent nuclear fuel train derailments involving impact to a spent nuclear fuel transport cask. We're also interested in analyses of forces to the cask from derailment and the likelihood of release of radioactive material from the contents of the cask or canister. Some metrics that we're interested in but are not limited include forces to the cask and wear, potential risk of release of radioactive material. We do have some references available, so if you are interested, please reach out to me and I'd be happy to share that. Some expected partners that we envision, but again, are not limited to the following, include research, consulting, cask vendors, science and engineering firms, and others. Our expectation for phase 1 versus phase 2, but again, this is not prescriptive, includes derailment modeling for phase 1 and potentially for phase 2 cask impact and release risk. So that concludes my brief overview of subtopic A. Jorge, if you'd like to take it away with subtopic B.
Thank you, Tran. I hope everyone can hear me, and I apologize for the background noise. So for subtopic B, we are the Department of Energy Office of Integrated Waste Management is interested in innovations that will result in the development of a system concept for a triple purpose canister that could support TRISO-based spent nuclear fuel, at least in a spherical pebble form. However, it could also be supported in a spherical pebble and compact forms. As far as the critical metrics that we are looking for a system concept that should support extended storage at a reactor site or a consolidated interim storage facility. It should be able to support transportation to and from a consolidated interim storage facility and or a permanent disposal facility. It must be transportable on the Atlas and Fortis rail cars. It should also be able to support disposal of the canisters in a wide range of geologies conducted for deep mine spent nuclear fuel repositories. And it should also meet applicable regulatory requirements under 10 Code of Federal Regulations, Part 71 and Part 72. The system concept may be designed to be capable of containing smaller disposable canisters within a large canister. However, this is not a requirement. In addition to this, we have some references related to the Atlas and Fortis cars, some previous work that was done for a small standardized transportation agent and disposal canister systems. However, these were done for light water reactor spent nuclear fuel. However, we believe this should be helpful for a triple purpose canister for TRISO-based spent nuclear fuel. And we also have references for TRISO fuel and TRISO spent nuclear fuel. So if you're interested in looking at those, feel free to contact Tran. And then for expected partners, we are not requiring any partners. However, anybody who works on TRISO fuel, such as vendors or advanced reactor vendors that are expected to use TRISO fuel, could be good partners. In addition to this, there could also be national laboratories and universities as partners. In terms of expectations between phase 1 and phase 2, for phase 1, the scope of the work will focus on investigating the feasibility and conducting the scoping studies for the development of a triple purpose canister system concept that would support TRISO-based spent nuclear fuel in a spherical pebble form and possibly compact form as well. In this phase 1, we're expecting to any awardee to conduct literature reviews and provide information that would identify any gaps. And the final goal of this would be to come up with a notional concept for a triple purpose canister system. And then for phase 2, after successful completion of phase 1, the system concept will be matured by performing the necessary calculations, shielding, criticality, thermal, etc., to develop a detailed design of a triple purpose canister Some of the deliverables expected would be computer-aided drawing, schematics of the triple purpose canister, 3D drawings that show the design of the internal and external components, as well as the canister being placed inside a transportation overpack and inside a storage overpack. In addition to this, a rough order of magnitude cost estimation for the triple purpose canister system will need to be developed. That's all for me. Back to you. Over.
Thank you. No questions. We'll move to the next subtopic. And we have John. Are you online?
If John is not available, this is Prasad Nair. I can pick it up.
Okay, go ahead, Prasad. Thank you so much.
Yeah, I have both C and D. Basically, both C and D deal with existing spent nuclear fuel, commercial nuclear fuel. And in C, it is about transportation and storage and transportation. We have on site in a lot of the reactor sites, many of these dry storage casks sitting there. And they are welded structures, and they're about 5/8 of inch, 3 or 4 stainless steel, and with a concrete overpack. It's all licensed under the storage requirements, but it was estimated that they would stay for about 40 years. Now, with the change in the overall strategy, we are looking at probably staying for more than maybe 100 years. What it does is, even though they are qualified and licensed, new additional conditions exist for these long-term issues. And the issues that relate are chlorine-induced corrosion cracking, or understanding the internal environment of the canisters, or then whether the fuel will degrade in this period of time, then understanding the stresses and strains on fuel bundle components due to transportation. Some of it will be addressed in the Atlas work that'll show up, and seismic effects on these things. And the other areas associated with this is something like any repair mechanism, remote handling. We have also looking at monitoring work on whether something is changing within the system over time, non-destructively. Just to highlight some of these things, we have been working in this area for about 10 years or so. And there are other programs that have gone into SBIR support programs and STTR also. I would suggest that people look for the already work done. Just look at OSTI publications. You'll get a significant amount of work. Why we are concerned still about certain things is there some novel technologies that can be brought to bear that will simplify things or give us greater assurance that the spent fuel in storage and while transporting has maintained integrity over a period of time. So that's essentially what we are doing, and there is multiple aspects of it, and work's being done in this area. So I would suggest go ahead and try and go to OSTI and see if you can get some of the reports. In fact, one of the reports has been cited in the solicitation already. So any questions on that?
No questions. Please proceed.
Okay, the next one is subtopic D. It is about disposal research. This is a pretty important area of activity that has also gone over for over 10 years. And we have done a significant amount of work about understanding how the waste is isolated in a geologic setting. Basically, the multi-barrier system, that approach that takes us, you have the spent fuel or high-level waste in a container, and the container is kept in surrounded by a backfill, and it is placed about at least half a mile underground in a geology that what we are right now looking at is generic geology, which includes argillite or salt or crystalline, basically, and looking at both saturated and unsaturated conditions over a long period of time. The idea behind this is to isolate the waste over a long period of time. The dose to the atmosphere is less over a million-year period. So it is not conventional way of doing engineering or analysis by itself. We have to deal with a lot of uncertainties in these things. So how do you capture the uncertainty, both in testing, analysis, and also be able to monitor things to the extent possible? So the things we are looking at then is, are there any novel methods that can help characterize barrier system performances? And then the other part to it is always looking at uncertainty quantification and sensitivity analysis. Unlike general analysis or analytical modeling, the modeling goes hand in hand with understanding how the uncertainties are defined and what parameters are sensitive to the long-term isolation of waste. Now, reducing uncertainty in data and models is a key aspect of our program. So if you find you have a new technique to do some of these things, it will be very welcomed into that. Then understanding long-term material degradation. We do understand some of the corrosion aspects and stuff, but staying long periods of time, how long would a particular canister last? But we don't depend on the canister performance alone for the long term. In the million years, it is all about the natural barrier also taking into consideration. Then in particular problems, we have in our storage inventory what's called dual purpose canisters. What this is storage and transportation containers, and they tend to be a bit larger than the normal storage containers. And what we would like to do is dispose these things without having to open it and place it and reshuffle the fuel and repackage.
Hello, Dr. Bond's office. This is Frank Goldberg. You've notified me that
somebody,
I should come in for a check.
Yeah.
I was just checking what your plans are.
If somebody can mute.
I'm free tomorrow. You can squeeze me in. But then there's the following week.
There's an overlap here.
Yes.
Anyway, so what the dual purpose canister has, one of the concerns we have is the criticality. So whether we want to fill the canisters with something so it avoids potential long-term criticality issues. So there are novel analysis or methods you can bring to bear on this stuff. Then there is also the data aspect of it. In geochemistry areas, people look at aqueous speciation or interactions, sorption issues. There is plenty of international work supporting this too. So when you look at some of these areas, you want to see what work has been done. In putting a hot waste form underground, it also reacts with the thermal issues and thermal hydrological and geochemical aspects of it. So then the other last but not least is the backfill material, whether we are looking at low permeability material. So the idea behind it is to prevent radionuclides moving from the place where we interned it to get to any accessible environment. So there is both uncertainty, both design, analysis, testing, And I would urge folks who would propose in these areas, come up with some novel ideas that might enhance our confidence in waste isolation process. Any questions?
I don't see any question in the Q&A box, so we can move to the next subtopic. James. Thank you, Prasad.
Yeah. Okay.
Yes, hello. This topic, if you think it looks very much like the advanced sensor one in 58-29, that's because I think this is in the wrong topic area, and it will be revised and updated. The other thing is, the other main thing about this one is, as written here, it implies measuring simultaneous viscosity and density measurements of molten salts, both on the benchtop as well as in situ in a molten salt reactor. We're going to emphasize, because the other one, the other topic area includes sensors for the benchtop. This one will be revised to include, to be focused on in reactor, either inline or at line measurements of simultaneous measurements of salt and density, which, I mean, density and viscosity, which will turn out to be very key properties of the fuel to make sure that it is staying within the qualification specs during reactor operation. So this call is for devices that can simultaneously measure salt, viscosity, and density in at high temperature in a radiation environment. I suspect it will be moved to the other topic area as well.
Thank you, James. I don't see any question in the Q&A box, so we can move to subtopic F. Kimberly, are you online? Kimberly? Kimberly, are you online? Okay, anyone is covering for Kimberly, subtopic F and G?
I can cover subtopic F.
Okay, go ahead.
Yeah, this is for capturing noble gas fission products, specifically krypton, over to selectively capture krypton over xenon at or near room temperature, as opposed to doing it by cryogenic distillation. Advanced functional materials that are listed here would be of interest, and as well as multi-purpose absorbents that would capture one or more of the volatile radionuclides listed: iodine 129, krypton 85, carbon 14 are also of interest. The goal is really to reduce the off-gas system footprint and size, and be able to capture disposal, to capture and sequester the radiokrypton. And topic G is for multi-radionuclide absorbents and waste forms. So this is for absorbents that have the ability to simultaneously capture more than one gaseous radionuclide from the off-gas stream, and then with a clear path to mobilization of that material into a durable waste form.
Thank you, James. I don't see any questions in the Q&A box for subtopic F or subtopic G. Thank you for covering.
Welcome.
Okay. As we mentioned earlier at the beginning of this webinar. We will post this slide and the recording of the webinar on our website under Funding Opportunities webpage. Here we have our contact information. Please feel free to reach out directly to Carl Hebron, who is the operation manager in our office. Carl and his team can answer just about any question you may have about the application process. Also, I would like to elaborate on Phase 0 assistance program is open now, and it's open for all first-time DOE applicants. So if you have never applied to DOE before and looking for application assistance, I would encourage you to go online. You can find the link here or on our website under applicant resources page and click on the link that will take you to the Phase 0 website where you can complete a 3-minute application to see whether or not you are fit for this service. It is a first come, first serve service, but it's something that can help you go through the application process. That will be it for today's webinar, and thank you for sticking with us and attending this webinar. Thank you and have a good evening.